Hello, the Math Dog here. In this video, I'm going to look at how to complete a square. This is an Algebra 1 video, though it could be showed in Geometry and Algebra 2, because completing a square often takes a student quite a bit of practice before they really get it down and understand it. So before attempting this video, you should be familiar with factoring trinomials. For example, x squared minus 2x minus 3, it's called a trinomial. It's a quadratic trinomial. It's got three terms in it. So let's just quickly review the one I've put right here. So what I'm going to do here is, if this is factorable, and this one is, I'm looking here in this simple problem for two numbers that multiply -3 and add up to -2. Well, 3 times 1 is 3. So, and I have an x times x here. So x times x gives me x squared. Now I have 3x here. I have 1x here, but I need -2x. So if I take the difference, I'm going to take a difference here, but I need more negatives than positives, so I make this -3 and +1. So this factors as quantity x minus 3 times x plus 1. You could check that using what we call FOIL. First, outside, inside, last. The first terms multiply to x squared. The outside terms multiply to x or 1x. The inside term multiplies to -3x, and the last term multiplies -3, and you combine your like terms there, so you get x squared minus 2x minus 3. I like to encourage students to, if they don't like FOIL, to check using what I call the box. So I have, say, x minus 3 times x plus 1, so that's x squared minus 3x plus 1x, and then -3. So you're multiplying everything to get what's in the box. Then you have like terms right here on the diagonal, so that's x squared minus 3x minus 2x minus 3, which is a check on our original problem, because we now get what we started with. Okay, let's get back to completing the square, and let's get started. So let's look at some perfect square trinomials, which is what we're going to be dealing with when we work to complete a square. So there were certain special cases of trinomials that could be factored to a binomial squared, and here's some examples of this. So in this case, two numbers that if this is factorable, and it is, should be able to write it like this. So two numbers that add up, that multiply to +9 and add up to -6 would be -3 times -3. -3 plus -3, because that's 9, that's -6. So this factors as x minus 3, x minus 3, which is x minus 3 squared. Now, you should be able to learn, and this is what we need to learn here, in these special cases, if you should be able to spot this. Notice if you take half of the -6, which is -3, and you square it. So half of -6 is -3. And then if you square -3, you get 9. And that tells you that this factor right here, you should be able to go right from here to here in these special cases as you get good at this, because half of -6 is -3, and you realize that -3 times -3 is 9. So in this next question, we have two numbers that need to multiply to 4 and add up to 4. Well, that's 2 times 2 is 4. And 2 plus 2 is 4. So I should be able to write this as x plus 2 times x plus 2, which is x plus 2 quantity squared. And that's what this factors to. So again, I should be able to, without having to do all this work here, I should be able to look at this problem, where I want you to get to the point where you can look at this problem and recognize, okay, well, half of 4 is 2. If I square 2, it's 4, so this has to be quantity x plus 2 squared. And when you check using the multiplication, using FOIL, for example, you would get that, because this is x squared, outside is 2x, inside is 2x, that makes 4x, 2 times 2 is 4, which gives us what we started with. So next one, let's just go right to the chase here. If this is going to be a binomial squared, well, two numbers that multiply to 25 and add up -10 would be -5, because -5 times -5 is 25, and -5 plus -5 is -10. So this factors like this. Again, if you have to, you can go through all these other processes, but we're working to get to the point that you can recognize this as what we call a perfect square trinomial. Okay. The next one now is a little more challenging. So the thing is, when you work to complete a square, and when you work to do any factoring of a trinomial, you want to see if you can get that x squared term to be 1. So you're going to try to factor out a 3 before you do anything else. Well, 3 times x squared is 3x squared. If this works, 3 times 14, actually negative 14, is negative 42, so we have that. And then if you notice, 3 goes into 147, 3 goes into 14, 4 times 3 is 12, subtract 2, bring down to 7, 3 goes into 27, 9 times 3 is 27, so you have 0 remainder. So this has to be plus 49. So now completing this factoring, that's a perfect square trinomial because two numbers that multiply to 49 and add up negative 14 are negative 7, negative 7. So I can write this as 3 times quantity x minus 7 quantity squared. And then the last one here, I do not want a coefficient of negative 1, so when I factor, so I'm going to pull out the negative before I do anything else. So that's the negative of x squared. Negative times negative here makes 2x, so that's got to be negative 2x, because when you distribute this, negative times negative is positive 2x, and this is minus 1, so that has to be plus 1. Okay? Well, now we have the negative of, and we can factor this as a perfect square trinomial, because two numbers that multiply negative 1 and add up negative 2 are negative 1 and negative 1, so this is x minus 1 quantity squared. So this is how this factors. These are all, again, binomials squared. They are perfect square trinomials. So literally, they are called perfect square trinomials because their dimensions form a square. So for example, x squared minus 6x plus 9 factors as quantity x minus 3 quantity squared, because two numbers that multiply to 9 and add up negative 6 are negative 3 and negative 3. So notice if you when you multiply these, x minus 3 times x minus 3, or quantity x minus 3 times quantity x minus 3, the dimensions are a square. So it's a perfect square. So again, if I factored this, and let's just suppose x is 10, then that would be on the sides of my square would be 10 minus 3, which is 7. 10 minus 3 is 7, so the area of that square would be 7 squared, which is 49 units. So because this is again called a binomial squared, it's called a binomial squared because it has two terms and it's squared. And each of those terms are squared, or to the second power. Alright, so now here's how you complete a square. This is not an equation, this is an expression. There's no equal sign here. So we're starting out by just learning how to complete a square. So first thing when you complete a square is you need to write this in descending powers of x. And to complete a square, right now, x has to be to the second power. Then you're going to need another term that is to the first power. So these are in descending powers of x. 2, and you could put a 1 there, although we don't usually do that. So second power of x, first power of x. So we've changed this to descending powers of x. Then you're going to take half of this 12 here. This is how you complete a square. You take half of the x term, okay? Half of 12 is 6. Then you take that 6 and you square it. So you take that term, you square it. That's going to be 36. So completing the square, you have x squared plus 12x plus 36. Then you factor that. Well, that's a perfect square trinomial because 6 times 6 is 36 and 6 plus 6 is 12. So this factors as x plus 6 quantity squared. So this is what we mean when we say complete the square. We go from this to this. Now these are not equal because we have a 36 added on here that we don't have here. So this is not an equation, but we are building an expression from x squared plus 12x to this expression here. All right, let's work through some examples here. So this is in descending powers of x. To complete the square right now, that needs to be a quadratic, a second degree term followed by a first degree term x. So what I do is I look at this. That's negative 18. So half of negative 18 is negative 9. Then I take negative 9 and I square it. That's 81. So this should be then, I'm adding 81 to complete the square. Well, this now is a perfect square trinomial which can be factored as follows. Again, two numbers multiplied to 81 and add up to negative 18 are not negative 9 and negative 9. So I can write this as x minus 9 quantity squared. And this is how I complete the square, starting with x squared minus 18x. Okay. So let's complete the square for x squared plus 9x. This one's going to give students a little more difficulty because, again, so to complete the square I take half of 9. Well, that's going to be a fraction, which is 9 halves. Then the rule is you square that 9 halves. So that's going to be 81 over 4. So completing the square, this is going to be x squared plus, and it's not equal because I'm adding something that wasn't there, x squared plus 9x plus 81 over 4, which is 9 halves squared. So this factors, now this does equal this. This factors as x plus 9 halves quantity squared, and if you want to, again, notice that's 9 halves, that's what goes there. So again, to show you that actually works, let's put this in the box. That's x plus 9 halves, x plus 9 halves. So that's x squared. So I'm reversing the process to check to see if this works. I want to see if I can get this expression. That's 9 halves x. That's 9 halves x. 9 halves times 9 halves is 81 over 4. Well, 9 halves plus 9 halves, I have a common denominator of 2, that's 18 halves, but 18 halves is 9, so we get what we wanted. These add up to 9x, that's x squared plus 9x plus 81 over 4. So here's another one that gives students difficulty. Okay, that's why I'm doing it, so you can start to see how this process works. So I could, again, this is in descending powers of x. I have a quadratic here. That's a second degree term, first degree term, which is what I need to complete the square. Remember, this is really 1x right there. So half of 1 is 1/2 times 1, because that's how we start this, which is a half. Okay, then we take a half squared. A half squared is a half times a half, which is a fourth. So I'm going to add a fourth here. But what I'm doing is when I factor this in, so I'll have this. So what I put in here is a half, because a half squared is a fourth. So this is the expression what I get when I complete the square. Okay, so notice again, if I multiply this out using the box, I will get this. So that's x plus a half, x plus a half, that's x squared plus 1/2 x, 1/2 x here, x times a half, and then a fourth. Well, a half and a half is 1 whole, so this is equal to 1x right there, which is what I have here. There's the fourth, there's the x squared. Now notice you can check the work mentally. If you get, for this one's fairly simple, but what I do is I go, okay, I can check this mentally. X times x is x squared. Multiply these two together, that's 1/2 x. When I double 1/2 x, I get x, or 1x, and squaring this, I get a fourth. So you can mentally check your work that way. If you do want to check it a little more carefully, you can make a box, or you could use the foil that I shown earlier. All right, now I got a decimal. So again, we're going to take this coefficient of x here. Again, this is I can complete the square because this is a quadratic second degree term. This is a first degree term in x. Well, half of 0.6 is 0.3, because 0.3 times 2 is 0.6, okay? So then I'm going to take 0.3 and I'm going to square it. Okay, well 0.3 times 0.3, that's 9. Carry the decimal point. There's 2 places behind the decimal point, so that becomes 0.09. So I add 0.09 here, and this will factor as x quantity x plus 0.3 or 0.3 squared. Again, you could check that in the box. X plus 0.3, x plus 0.3, that's x squared, that's 0.3x, that's 0.3x, that's 0.3 times 0.3 is 0.09. 0.3 plus 0.3 is 0.6, in this case x, so we have x squared plus 0.6x plus 0.09, so this, to complete the square, you get this for our original problem, which was this. Alright, stop the video and do these practice problems. So when you're done, turn the video back on and check see if you agree with what I got. Okay? So in this one, I'm taking half of negative 16 to start with. That's negative 8. Okay? Then I take negative 8 and I square it. That's 64. So I'm going to have x squared minus 16x plus 64. Okay? But that factors to this. That's going to be x, and it's going to be minus 8 quantity squared. Okay? Checking it mentally, that's x times x is x squared. Multiply these, that's negative 8x, double it, gives you negative 16x, square negative 8. Negative 8 times negative 8 is 64. If you have to see it in the box, here it is. Negative times negative makes positive, so this is x squared. Combine those terms, minus 16x plus 64. Okay, stop the video, do this problem, start the video again, and check your work. Okay, here to complete the square, I take half of 26. Well, half of 26 is 13. Take 13 and square it. That's 13 times 13 is 169. So I'm adding 169 here. And I've got a perfect square trinomial now, so I can factor it as a binomial square. That's going to be x, and that's got to be plus 13 quantity squared. Mentally doing this, that's x squared. Double 13x makes 26x. Square 13, that makes 169. Okay, stop the video. Complete the square for x squared minus 1/4 x. Okay, so in this one, I'm going to take 1/2 of negative 1/4. That's negative 1/8. So now I take the negative 1/8 and I square it. That's 1/64. So follow this process. You take half of the coefficient of the x term, you square it, then you add it to the end. Okay, and we're going to put negative 1/8 inside the parentheses here, and that gives us this right here, and let's just demonstrate that in the box. So I have negative 1/8 times negative 1/8, that's positive 1/64. Notice that negative 1/8 plus negative 1/8 is negative 2/8, but that's negative 1/4. So this checks out, because this is going to be x squared minus 1/4 x plus 1/64. Okay, last one. X squared minus 0.1x. Okay, so again, following the process, we take half of 0.1, negative 0.1. Okay, well, what's half of negative 0.1? Well, 2 goes into 0.1. Okay, we just move the decimal point straight up here. Okay, it goes in there 0 times. 0 times 2 is 0. Bring down the 1. Add a 0 here. Bring it down. 2 goes into 10 5 times. So this is negative 0.05. Okay, so then I take negative 0.05 and I square it. Okay, So 0.05 times 0.05, I'll have 4 places behind a decimal point. That's 25. Ignore the decimals for a moment. That's 0 times 5 plus 2 is 2. Add a placeholder 0 right here. Then 5 times 0 is 0. 0 times 0 is 0. So I have 5, 2, 0. And I need 4 places behind decimal points, so I need to add a placeholder 0 here. 1, 2, 3, 4. So this number is going to be, so I'm going to add here plus 0.0025. So if you understand the process of completing a square, which is again take half of this and square it and add it here, this, if you look at this, you're going, how did I get this? Well, if you follow the process, you will get this. So let's check that. Okay, so this factor, before I do that though, this factors to this. Okay, we know this is minus 0.05 y squared, so let's check it in the box. So that's x squared minus 0.05x, that's minus 0.05x, and then 0.05 times 0.05 we just showed was 0.0025, and by the way, reading that number, that's tenths, hundredths, thousandths, 10,000. So as a fraction, you would say that as 25 10,000ths. Okay, those two terms right here add up to they're both negative, so you add more negatives, you get more, add two negatives, you get more negatives. That's going to be negative 0.10, which equals negative 0.1. So this checks out, and this concludes the video. If you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others, and I please would ask that you do if you liked it. Thank you very much. Have a good day.